Hi, and welcome to Conversations with Des. I'm your host, Des Blanchfield. Now, today I have the privilege of being joined by Lynn Comp. Now, Lynn is the Vice President for Data Platforms Group and General Manager for Network Platforms Group at Intel. Lynn, great to see you. Thanks for making time to catch up with me. Welcome to the show.
Thank you so much, Des. I'm excited to be here.
Now, you've had some really exciting announcements, and I'm going to just quickly recap them before we dive into a couple of questions, if that's okay.
Yeah.
You've announced a couple of really exciting platform offerings. On one side, you've announced a second generation suite in the Xeon family in the server space. And on the other side, you've introduced a whole new platform, a system on chip offering in the form of the Atom P5900, which I'd like to get into. To me, it appears like this is one of the broadest silicon platform offerings in the 5G network infrastructure market to date, which is pretty exciting. Clearly positions you ahead of the market in that space. I wonder if we could dive into, let's just start with the Intel Xeon new offering to start with. You've introduced a whole new offering in this space. I wonder if you could give us a quick 30,000 foot overview of what actually is included in the new Xeon suite, and then we can sort of dive into a little of the detail that goes into that.
So we're super excited about Xeon Scalable, the second generation Xeon Scalable. Like every other time that we're trying to launch Xeon, we get really excited because it's more cores, more cache, more frequency. And that sounds like a lot of technical feature talk. But what it translates into for customers is up to 36% more performance. Or if you're more in the performance per dollar TCO calculation, it's closer to 42%. Wow. And the other thing that's really exciting about Xeon Scalable and this processor line is it's really the only CPU line that has AI acceleration built in. And it's really important because a lot of our customers are trying to integrate their normal compute workloads and then add in inline inferencing or some new use cases. So another thing that we're really excited about with the second generation Xeon Scalable is it's up to 6x more AI performance than what we've been showing in the past. So really, really exciting for hyperscalers, for enterprises, all sorts of different capabilities. The other thing that we do love about Xeon Scalable second generation is we have some end SKUs to the question about where's my Moore's Law? 10 or 15 years ago, the comm service providers came to us and said, hey, where's my opportunity to get on this application spiral? I'm stranded. I need to have some way to get on there. And the end SKUs in the second generation Xeon Scalable were really excited because it gives them up to 50% more performance on their version of the software-defined journey in their infrastructure that we're calling NFV, or Network Function Virtualization.
Yeah, it seems to me that there's always this challenge, isn't it? Because there's a long lead up to the development and design of hard things, physical hardware, and particularly the form of CPUs, and the software world and the technology that goes with that, and the business problems that are being solved tend to move really fast, and there's some big sunk costs in that. And you've been faced with a whole range of challenges, as you said, hyperscaling, cloud, virtualization, big data analytics, and now machine learning inside the artificial intelligence space. And then along comes the telco, software-defined infrastructure and software-defined networking, and as you said, network function virtualization. So it seems to me now that you've managed to get from where we might have had to bolt, GPUs and FPGAs into server platform infrastructure, you've now managed to design a platform that you've built this all into it and essentially baked it into the DNA. Is that a fair description?
The way I love to describe Xeon's portfolio is it's wonderful to have a hammer that you hit everything that's above a flat surface like it's a nail. However, at Intel, the beauty is you have the whole toolbox. You've got the entire portfolio. And one of the opportunities that we have in working with the service providers is we really learn what are the anchor points for tuning their service profile. So sometimes you absolutely will have the best opportunity in using a CPU in Xeon because you need that kind of complex compute capability, or you need multi-tenancy, which you can get with the CPU and the Xeon architectures. So you can have multiple different hosted applications all running different things. At the same time, we do actually have, as part of our 5G portfolio that we talked about, we added some really exciting news about something called Diamond Mesa, which is a structured ASIC. And so it's sort of between an FPGA in terms of programmability, but some of the hardening and power benefits that you would get from more fine-tuned logic. So we're trying to not constrain our customers, but give them choice at what we think are the biggest decision points for how do they deliver a great service.
Indeed, and I think what you've managed to do more than anything is provide them that flexibility they've been looking for, and they've effectively got one platform that can do multiple workloads at high performance, as opposed to having to have a lot of additional infrastructure and potentially more and more racks of infrastructure to get that performance. And as we move to more and more software-defined infrastructure, I think that's going to be one of the biggest challenges that all of these players, particularly in the telco space and more so with 5G, that we're going to be faced with. That we don't know what the workloads of the future are yet, but we need that intelligence at the platform and inside the software that runs in that. Now, on the other hand, you've also introduced a whole new exciting offering in the form of the Atom P5900, which I understand is a system on chip. I wonder if you could maybe just introduce what that is as far as the platform itself and why you went down the route of system on chip, and then we can sort of talk about some of the opportunities that that's opened up.
So one of the things that we try and traverse is all of the equipment, and there's a lot of edges between the hyperscale data center and the consumer. And some of them are very power constrained, and they're really much more throughput oriented. And so with the Atom P5900, what we were really focusing on is bringing the instruction goodness and flexibility of the CPU. So you get about 1.8 times better integer performance than the last Atom generation, which is great because there's a lot of calculation in managing 5G. On the other hand, we needed to hit that optimal ratio of performance to watts and include some acceleration for packet throughput, because when you're in a base station, that's one of the first connection points for a signal to hit and then go back through the rest of the network, finding the right addresses for it to be received to the right recipient. So what we love about the Atom P5900 is you're not giving up the programmability, the flexibility, the software tools that you'd be used to using in other parts of the network or other data centers. But at the same time, you're getting that performance for packet processing throughput, as well as a better power profile for something that has a little bit more of a hard limitation, just based on the radio towers and other things that are at that location.
Yeah, I think there's an ever increasing need to have low power but high throughput. Am I correct in understanding that the real remit for this, and more than anything though, is that whole edge networking, edge compute space where you have more of a switch fabric challenge, as you said, with high integer capability, and less so much the traditional enterprise workloads. We're not really running Excel and Word out here. We're running switch fabrics, creating circuits, routing calls, routing video, and delivering to the end, but still really having to have the intelligence there that we need to be able to do some processing, whether it's out in the field or on top of a pole or on a wall somewhere in a computer room in an enterprise environment. I imagine that's kind of the approach you took with regard to going down the system on chip as opposed to just another ASIC or applicated integrated specific circuit, for example.
So what I would say, the edge is becoming redefined. 5G is such an interesting technology because it's not just the mobile and the smartphone. It's actually a combination of compute and communications, where there's 3 different use cases, 3 different profiles. And a lot of those new use cases, the IoT examples, the factory, the agriculture, is made possible to be economically feasible with network slicing. Well, how do you do network slicing in something that's not software defined? It's really, really difficult. So we end up bringing in that enough of the IA performance for that location to be able to do the right features for 5G. What's really fascinating though is you'll find a lot of different formats in some cases. Like you'll have more processing, sometimes closer to the radio, and there are network operators who put the processing 15 miles away from the radio. So we're giving them a range of choices.
Right. One of the exciting things for me with this is that there's been a whole range of new and emerging markets, particularly around the telco space and certainly around 5G, as we've been talking, that have come along, and now you've addressed those. I know I saw some of the announcements come out recently that I believe it was Ericsson was one of the early adopters of this. I wonder if you could walk us through the journey that the likes of an Ericsson would go through from where you were still probably in early design, you were sharing information with them to go through what you're building, to the point where they can go through their own design and get ready to actually put this in this platform itself into their own environments, whether it's an access point for 5G cellular environments or other use cases. I wonder if you could just give us a walkthrough on that whole journey that likes of Ericsson might have gone through with you to get to the point where they've got a 5G base station that's powered by the new Atom P5900.
So the interesting thing about the 5G journey is that you have to design for flexibility, and at the same time you have to have things hardened enough that will make the power profiles fit. And so one of the things that we put in there as a general capability is something that is basically a way that we can do load balancing and packet processing. So if you use the hardware acceleration on the P5900, then you can dynamically load balance the control of the packet processing against the number of cores dedicated to packet processing. So if you're finding that you really, really have to have more throughput, it can dynamically move over to the hardware scheduler so you don't use any of your cores for processing any of the packet controls. Now, there's some customers that are going to use their own software because that is how their base station software has been configured, or it's the best way for them to integrate into the operating and billing systems. But many of them have found using that logic means they get more cores for more throughput. And that's something you might need for the 5G use case where you're doing ultra-mobile media transport. You got to get as many packets through as possible. Now, if you're looking at something that would be more like an IoT use case, where you're just tracking a sensor and you don't really need a high bandwidth, low latency channel, you just need something that connects at the right amount of data throughput, then you can go ahead and use Atom P5900 with the software scheduler, because you really don't necessarily have to have as much of the packets, but you can leverage the compute. So it's very, very flexible in being able to deliver the flexibility that 5G requires. I mean, 3 use cases, not just smartphones, it's a completely new ballgame.
I described this to someone the other day by saying that I see this as not just another stepwise increment in performance, as I said earlier on, but more so a significant transformation in that you've pivoted to meet these new emerging markets in a significantly powerful way, that you've given them all that flexibility, but also with a future-proofing that we don't quite know what all the workloads are going to be. And what I see is one of the fastest growing markets surrounding the 5th generation networks, AK 5G. I wonder if you can tell us a little bit more about the pivot itself, and particularly some of the markets that it's opened up. And obviously, we've got the traditional spaces of switch fabric, and you've got 5G base stations, whether it's in a building or the top of a pole. But I imagine that there's, as you said, there's Internet of Things, there's autonomous vehicles. This must open up a whole range of new exciting markets for you.
Yes, it is. The thing that I also believe a lot of people, including myself, forget to mention about 5G is the management structures cover both licensed and unlicensed spectrum. And so that gives you an on-ramp into private enterprise networks where you can mix and get a better decision profile for those IT professionals that they might want quality of service in range, but they haven't necessarily found a way to do that in Wi-Fi. So this gives them a bit better control over what they can do that's essentially close to the network or in their factory floor or on-prem. So 5G gives you such a bigger range of profiles. Having the basic connectivity with that included flexibility of having an IA core, you can go with Xeon or Intel architecture all the way from the hyperscale to the edge, to the far edge. And then the consumers end up seeing this benefit in the choice of network profiles, as well as what they can use the network for. A lot of what has, I'm told, held IoT back isn't the fact that the networks can connect reliably. It's really, most of those use cases don't need the full channel. And yet, to get the channel, you have to pay for the full channel. So the 5G controls plus the unlicensed spectrum, I believe, is really going to unleash this wave of innovation in robotics and industrial. One of our demos, a robotics-oriented controller, and it had both Wi-Fi 6 and it had 5G in it. So really exciting opportunities to not have such a constrained one-size-fits-all network, but be able to build on top of it in very unique ways.
You must have had a very positive response from both your existing customers as well as potential new customers who are coming to you for different types of challenges where, as you said, when you think about that whole end-to-end journey, historically we may have had a lot of different proprietary platforms to write code for, to integrate. It seems to me now, from the system-on-chip Atom P5900 right out of the edge of the network and the cloud sort of, in-field stuff, all the way down to the data centers and the centralized cloud spaces, you now have the seamless platform where the code that runs out of the edge of the network or in the devices moving around, capturing the data, whether it's an autonomous vehicle or a robot, all the way through that network infrastructure to the centralized data centers or the cloud. This is a common platform, and if the logic has to follow it, it can, and it runs natively on these. I see this as such a significant game changer. What's the reaction been from the market once they've realized this?
It's a lot like every generation of technology. They can you can sense the possibilities,
Right.
but you're not quite sure you've really scratched the surface of the opportunity. And a great example is, rideshare applications. 10 or 15 years ago, it wasn't the normal state where you could be so flexible and being able to get a ride anywhere. And there are a lot of technologies that came together to make that kind of use case completely normal. Another great example that I love is if you look back 2007 timeframe, Netflix was still being consumed with mail order envelopes all in the US. And now what is the normal use case? It's any screen, it's any region, it's region specific. And so if we look at what some of those innovations have unleashed in the past, you can only project forward how much innovation is possible. And it's really putting much more flexibility both in our customers' hands so that they don't have to make choices of software flexibility versus power efficiency. We're giving them knobs to tune from the cloud all the way out to the base station. At the same time, we believe we're helping their customers innovate in a much more powerful and flexible way.
It's an exciting time. In fact, one of my favorite quotes is I say that it's an exciting time to be alive. I wouldn't want to be alive at any other time when I see the sorts of things that are coming out to the market, particularly both what you've done now with the Xeon second generation platform and now the system on chip with Atom. I wonder if I could maybe ask you one last question then before we wrap up. What are some of the things over the next 12 to 18 months or 3 to 5 years potentially that you're seeing that could potentially be whole new markets that you can move into in the space now that, as you said, rideshare was an idea we hadn't even conceived, and now no one imagines could imagine what life was without it. You probably got a fairly unique view of the world in this sense. Do you have a sense of some of the new emerging spaces that we can anticipate that are coming to us soon?
So the categories that keep coming up are things like interactive experiences. A lot of the creators get very frustrated by the fact that they have to bring the audience to them to experience what they have in their minds or their vision, and they're struggling to get that out to the audiences that they want to be able to touch people where they are. So, one of the first use cases that was deployed in Korea for 5G was media delivery, because people want to be able to watch videos all the time. It's not a text world anymore. The ability to have that more interactive and that more experience-based thing where you're interacting with the community. And it's this community feeling that they're really, really striving for. And one of the things that made some of the games go viral is that worldwide connectedness. So I think that that's one opportunity that people are just dying to start pursuing and really finding those amazing experiences. Then the other part is like industrial, for example, or fleet management. We talk about autonomous driving and robo-taxis and things like that, which are great, but just basic fleet management of where people are and finding out that you should never take a left turn on the routes and you should optimize for right turns. Those kinds of insights can be accelerated with some of these capabilities. And so when you look at what did it save some of the delivery companies when they discovered no left turns, right turns only, what if they got that years earlier? And so they were able to give that experience and more predictability in their deliveries. There's so many optimizations that can be done to give the consumers the experiences and access to the brands that make them passionate, be able to be participating in the stories that they love, and maybe even tell their own version of that, or even just basic consumer services. I think it's going to be mind-blowing when we look back 10 years from now and look at everything that's been innovated.
In fact, there are two things that came to mind just as you're speaking there that I've recently had in panels that I've hosted that people said, and that is that what they're seeing coming out of Intel now is giving them two big wins: reduced time to market, which is always exciting, and reduced time to return on investment. That their investment in development and software and other things that they need to worry about at the infrastructure level has shortened. And I think those two things are going to make everything you're just talking about there so much more possible, because we can now imagine an idea and get it to market quickly, rather than potentially years and years and millions of dollars of investment. Well, Lynn, it's been an absolute pleasure to catch up with you. I really appreciated the insights you've given us on both the new second generation Xeon family and the amazing things it brings, and particularly the Atom P5900 system on chip, because I think, particularly in my world where everything's out in the field and the edge in the 5G world, I think that's such a game changer that we're going to take a little while to come to grips with what's actually possible with it. And I'm just imagining what, as you said, the next 3 to 5 years is going to be possible. And we'll be keeping a close eye on what you're doing there and some of the new innovations you're making possible.
Great. Thank you so much, Des, for having us. We're super excited, as you can tell, about just the possibilities that are being unleashed.
Indeed. And folks, thanks for tuning in and viewing. Now, I invite you to visit a website to learn more about this. It's on networkbuilders.intel.com/solutions-library. So that's networkbuilders.intel.com/solutions-library. And reach out to Lynn Comp directly. She is at comp_Lynn, that's COMP_LYNN on Twitter, and you'll find her on LinkedIn as well. And throw all of your fun, curly questions at her. I'm sure Lynn and her team would be more than delighted to hear from you and take on some of the new exciting challenges around the next generation networks, and particularly 5G. Lynn, thank you very much again.
Thank you so much, Des. I appreciate it.